computer. Yeah, so aloha again, everybody. Very, very thankful to Kevin Weng for making time to share his research with us today. And I'm just gonna hand it over to you, Kevin. He has about 20 minutes to present, and then we'll get into discussion and save your questions or add them to the chat. And once he's done with the presenting, we'll make our way through and learn how we can use this what he shares to better our resource management efforts. So with that, aloha and mahalo, Kevin. All you.
Awesome. Thanks very much, Nigel. Thanks, Koʻa, for the opportunity to hang out with you guys, and thanks everyone for coming. So this is a project that this group of us put together kind of early on during the COVID shutdown, and we were, everybody was trapped in front of their computer, and we were trying to think about if there was some way we could learn something about this using this huge global catastrophe as some kind of a natural experiment. And so we decided that because it had basically turned off all of the tourism, that was a good kind of a experimental treatment that we could use to try to learn something. So we put this project together and started doing some monitoring work as well as some fish tagging work and stuff at Molokini. So one of the key people was Russell Sparks, who probably many people know. He's the main Dara biologist on Maui. And Laura Gajic was at that time also at DAR. She's now moved on to NOAA. And then Alan Friedlander and Whitney Goodell are with the National Geographic Society. So this slide is pretty unnecessary for you guys. Obviously, ocean health is extremely important in Hawaii. You guys are probably some of the leading experts on this topic, so I'm not going to spend any more time on that slide.
Kev.
Yeah.
Sorry, it's not advancing on our side, or at least for me.
Oh.
I'm still seeing your title slide.
You're still seeing the title slide. Let me try going into the presentation again.
Yeah. Thank you.
Did it advance?
Not on mine's.
Not on yours.
Yeah, not on anybody's.
Let me try. Okay, let me unshare and reshare my screen. Maybe that can. Okay. Are you seeing the whole PowerPoint now with all the?
Yep, looks good now.
And how about now? Did the slide just advance?
Yes, we're on Start Advertiser. Oh,
okay,
yep.
Great, awesome.
Looks
okay,
good.
So this was my second slide. Sorry about that. So obviously the health of our ocean system is really, really critical in Hawaii for all kinds of reasons, cultural, recreational, everything. And amongst the large number of different stresses on the marine environment is the presence of human beings, which is partly a result of tourism. So we wanted to understand this a little bit better. There's a lot of focus on fishing as it impacts coral reef systems, fish populations, and Alan Friedlander and colleagues have done a lot of work on this over the years, looking at different amounts of fish in places that have different intensities of fishing. The the graph on the lower right is from this Friedlander et al. Paper showing that in the purple bar, the Northwest Hawaiian Islands has way more fish than other places. And as you get, basically as you move towards Oahu, you move along a gradient from more fish to less fish. So that's not going to surprise anybody. We wanted to kind of shift gears a little bit in this study, and instead of looking at fishing, we wanted to just look at what happens just when human beings are present in the environment where the fish are, and see what impact that had. For the MPAs, or marine protected areas in Hawaii, there are, again, there's kind of a gradient of fish biomass depending upon probably local ecological factors, as well as the amount of effective protection that is actually happening for each one of these. So you can see on the left side places like Kaho'olawe and Kalaupapa that have really effective protection, or are very remote and just don't have a lot of people there fishing. They have high amounts of biomass. And then on the right end of the scale, you've got some areas of in the very urbanized parts of Honolulu that have lower biomasses. Molokini is lying more towards the kind of more healthy end of the scale here, with a circle around it. Are you guys able to see my mouse moving around? Okay.
Yes.
So, it's certainly not Northwest Hawaiian Islands pristine, but it's in pretty good shape in the overall kind of spectrum of coral reef habitats in the main Hawaiian Islands. So here's just a map that shows where all of those different places are. Molokini is right here between Kaho'olawe and Maui, the kind of south corner of East Maui. And this pie graph in the side is showing how much of the total nearshore ocean environment is in different types of management regimes. So that little red sliver that's very small, that's the fully protected MPAs, and then this larger green Pac-Man bite is the majority of the nearshore habitat that does not have any kind of partial or full protection. This is a view of Molokini kind of under normal business as usual conditions. There's quite a lot of visitation by both tourist boats and private boats. And you can see here some of the tourist boats here. Some of them are quite large and can carry large numbers of passengers. And there's a whole variety of different tour boats. And then you might see some private boats. Probably the private moorings are over in this section here. So this is probably, these might be private vessels here on the private moorings. So with the large amount of visitation, we wanted to use the COVID kind of perturbation or experiment to ask if there was going to be any change in what's happening with fishes when suddenly all of the people disappeared. So we went and we set up a fish tracking system around. So this sort of tennis ball can cylinder is a listening station that's going to listen for audio signals from tags that we're going to put into fishes, and that will let us understand whether or not a fish is near this receiver. And we put the receivers inside and outside of the crater so that we'd be able to tell if the fish were in the inside kind of shallow sheltered area or on the outside deeper wall kind of habitats. Then we tagged some fish. So here's a little tiny papio that has been tagged with an acoustic tag swimming away. The way the protection system works at Molokini is that this area in blue on the inside of the crater is fully protected from all fishing And this donut ring around the outside of the crater allows people to troll by. It basically, if you're going somewhere and you got your lines out and you just want to pass by just to see, if there's some pelagics hanging around, that's legal, but you're not allowed to stop the boat and use bottom fish style or jigging style gears, and you're not allowed to spear by diving. So this red donut is only allowing trolling. So there's kind of two different levels. And one of the things that is really critical about Molokini is that because the DLNR does not have a huge number of officers that can be everywhere at all times, all at once, it's not possible for DLNR by itself to always have a presence here. But because it has a really, really active tour industry, every single day of the year, there's going to be the tour operators out here. So they actually have their eyes on the prize. And this is a group of people that cares deeply about this place. Their businesses are totally reliant upon it being a high quality marine environment. So they really care about this place. So that's a really effective way for this place to get monitored. So if there is any illegal fishing going on out here, it's probably not happening at times of day when the tour operators are out there. It's still possible it could happen because there isn't any tour activity at night or in the late afternoons. But that kind of eyes on the prize of the tour business operators is very, very important. Here's a video of Alan Friedlander conducting a survey on the outside wall. If you guys have ever been diving at Molokini, it's a really, really amazing environment with these near vertical walls on the outside. Really an incredible place. This is a graph of how many people are visiting Molokini, and you can see that there's a high amount of visitation, and then in this yellow box, when the COVID pandemic happens, it drops down to almost zero. And then once the travel quarantines for the state of Hawaii were lifted, it came back up again very rapidly. And I don't know if I was kind of bouncing back and forth between Oahu and Maui at this time with this project, because I live on Oahu, but I was obviously traveling a little bit to Maui during this time to do this project. And Oahu has a lot of tourism from Japan, and I think Maui has a lot of tourism from mainland US. And the mainland US tourism came back with a fury really fast. I don't know if anybody on this call is on Maui, but it was amazing how busy it was right after that travel quarantine was lifted, whereas on Oahu, there wasn't nearly as much of a surge of tourism because Japan was still shut down at that time and was for a long time afterwards. One of the things that Alan and Whitney and the other diver surveyors noticed was that there were species coming into the inside of the crater that were not typically sighted at all in that environment. So this is a school of white-tongued jack. So it's related to the oluas and the omilus, but it's a different species that is a little bit more shy and is typically, it's known to be obviously in our area, but it's not something that had been normally sighted inside Molokini by divers. And a big school of these things came in after a couple of months of the shutdown. So the quietness that was happening, kind of these fishes didn't come in immediately, but they were exploring their territory, and they realized that there had been a real decrease in human activity, and so they slowly started to perhaps to come back into habitats that normally they would be using, but that they have been displaced from because of high levels of human presence. Another thing that is of large concern statewide is herbivorous fishes. And so these surgeon fishes are obviously important herbivores that are cleaning the reef of algae. There are very robust populations of herbivores at Molokini. And one of the things that we noticed in our study was that there wasn't actually a very big response from herbivores when the humans disappeared, whereas the response was stronger among predators. So it seems like this kind of fear response of fishes getting scared off by the presence of humans is happening more with the predators. Cheesy soundtrack. This is just a little bit of looking around. At one of the very, very shallow areas. So this is the area that's called reef sand. So you can see it's only 1 or 2 feet deep here. So this is an environment that in a place that's open to fishing, it would be very easy to access a place like this because it's shallow, it's easy to get to. And you can see that at Molokini, there's a really, really vibrant population of Nanue and other species there. Okay, so what did we find from the diver surveys? This is some data that was collected by DAR, by Russell Sparks' team from diver surveys. And it shows that the biomass jumped up in 2020, which is the time of the COVID lockdown. And then it went back down once the tourism resumed. Now, the time scale here is way too quick for this to be the population growth of fishes, right? It takes a year to several years or even more for a fish to grow up and become mature and have babies, and for those babies to grow up. That's not what we're looking at here. This is happening in a really short, fast time scale. This is just fishes moving in and moving out. So it's really, really important when you're looking at a graph like this, and then when you're looking at one of those Friedlander graphs of how much fish there is in heavily fished versus lightly fished areas, this is a whole different thing that we're looking at here, right? Because in the Friedlander graphs where you're comparing over 20-year time periods, or you're comparing one place to another that have different fishing levels, there's actually fish getting removed from the system that are no longer there, right? So you actually have less biomass. This biomass we're looking at in this graph, this is fish that are all still alive that have just swam to different habitats. So this jump up in biomass in 2020 is fish that came to Molokini and lived particularly in the shallow inside of Molokini, and that got counted by the diver surveyors. And then when the tourism resumed, those fish swam back out into deeper waters. So they didn't get killed, they just moved to a different place. If we look at which types of fishes were influencing the changes in biomass, so this is one of Alan's principal component analysis graphs, and these presentations are they're kind of brain twister presentations because the labels on the axes, they're very hard to distill into anything that's really meaningful, because the whole point of the principal component analysis is to take a very multi-dimensional system and stick it into only 2 dimensions so that you can plot it on a graph. What that means is each one of these axes has a bunch of different things in it, which muddies what label we can put on the axis. But when we look at different species as represented by these arrows, it can tell you which things were increasing. And so one of the most important things, if you remember, that big jump in fish biomass was in 2020, in early 2020. So that was driven mostly by these species here for this time period. And so that's the things like aluas and omilus and this white-tongued jack species. So the strongest driver of the increase in biomass during the shutdown, when there were no people at Molokini, was these predators. Here's an image of Alan doing a diver survey after the resumption of tourism, once we had a high biomass of people back again. And so you can see that there's just a large number of people in the environment. You've got some scuba divers, some snorkelers, you've got a snuba group here. And then you've got Alan here counting his fish. And you could super high live coral cover here, right? Molokini is in really great shape compared to a lot of other areas. But this high presence of human beings had kind of pushed some of the fishes out into the deeper waters, and so they were not getting counted by the divers after the resumption of tourism. From the fish tracking data, we saw that the predatory species were less abundant when there were more people. And so on the horizontal axis here, this is the total number of people that are at Molokini. And then on the vertical axis here, this is how many times we detected our tagged omilu. And so when there was less people, there was more omilu. So again, this is not omilu who are getting killed. This is just omilu choosing to either be in the shallow inside or the deeper environments away, either on the outside wall or maybe have left Molokini entirely. So this is a change in habitat use. So we saw this big contrast in how much predator fish there was. So on the lower right here, I think that's an image of Whitney doing a dive survey, and right in front of her is all of these white-tongued jacks, versus once there was a big resumption in tourism on the top left, there's less predatory fish and a lot of people. So we utilize this kind of natural experiment of COVID in order to try to do like an experimental, obviously not us, but we use that experimental treatment to try to see if there was an effect. There was an increase in fish biomass, primarily of predatory species. Again, this is not an increase in fish because they're living longer and reproducing more. This is a much shorter time scale than that. This is just fishes choosing to utilize different places, different habitats. When the tourism resumed, the biomass returns to pre-pandemic levels. So again, those fish didn't get killed when the tourists came back. They just swam into deeper waters because they got displaced from the shallow interior environments. For some of the species, it may actually be, there may be value in utilizing those sheltered habitats. Things like an omilu, it's a medium-sized predator. It's still vulnerable to sharks, possibly, marine mammals. So it might want to have access to some shallow water sheltering habitats to get away from these really big predators. When we're pushing all of those medium-sized predators out into the deep, they're less able to shelter from the really, really big predators. So there might be some ecological effects that are happening because of these displacements. So the management of these non-consumptive uses is important alongside the management of fishing. Obviously, if I go out and spear that omilu and have it for dinner, that's a heavier effect than a tourist pushing the omilu to deeper water and then leaving, and then the omilu swims back into its shallower habitat. So clearly the severity of impact of me killing a fish is heavier than the impact of a tourist just pushing the fish out for a day. But because the tourists are going to be there 365 days a year potentially, even though that impact seems very, very incidental and quite mild, if you make that impact on that fish every single day, it may actually add up to something. So that's kind of why we're interested in adding this on the radar screen for DAR for their management of marine systems. So thank you guys very much, and maybe we can talk story a little bit about this stuff.
Very cool. Thank you, Kevin. I have a lot of questions. I'm gonna try to squeeze one in, and then we'll hand it over to everybody else. But it does sound like more of a habitat utilization effect, I guess, the tourism.
Mm-hmm.
And then even your pictures looks like a lot of I don't know if acoustic traffic is something, or just bodies in the water,
Yeah.
bubbles everywhere,
Mm-hmm. Yeah.
I guess my question is there currently any rest days from tourism in Molokini, or has there been? or it's just
Um,
open all 365?
so they don't have a rest system like Hanauma Bay has, which I think now is it both Monday and Tuesday now? It was one, but it might now be 2 days per week for Hanauma Bay. I don't believe that Molokini has any rest days like that. One of the things that it does have, and this is just an impact of the really powerful Ma'alaya winds, is that it's so gnarly in the afternoon that the tour boats typically try to get there early and they leave by 11 a.m. or lunchtime to avoid those winds. So there's kind of a natural system by the weather to create a little bit of a rest in the afternoons. And there also is no tourism at night. Yeah.
Right on.
Damien?
Yeah, Uncle Damien.
Mahalo, Kevin, for presenting for us. I want to ask you a question about Hokkien. You were talking about the absence of predators because of the tourists. Uh, in Hokkien, there's a lot of tourists that swim to swim with the dolphin. So in the past 20 years, the akule didn't come into the bay. Uh, I wanted to ask you uh, if you think maybe the people in the bay keeping the predators out impacted the akule coming into the bay to seek the shelter of shallow waters.
Yeah, I don't have any direct information on that, but I can certainly imagine that a really large amount of activity with a lot of snorkelers and boat traffic might displace the akule. I mean, we could also think of it the
Yeah,
other way around, is if we push all the big stuff out, then maybe it's better for the akule. But I mean, the akule was already coming into the
I,
shallow sandy areas naturally, right, for shelter, probably because
right.
it had less in the way of big stuff.
Yeah, to escape the predators like the
Mhm.
kamano and some of the pelagic fish. But when the swimming with the dolphin increased, the akule didn't come in for 20
Mhm.
years.
Okay.
So I think there's some kind of correlation there between the opelo, the akule, and the naya, the dolphin. And I
Mhm.
don't know what their
Mhm.
roles are in the ecology of the bay, but when you add something in there that changes the behavior, I think you can kind of surmise that 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 addition affected how the fish behaved.
Mhm.
It's
Mhm.
just my thoughts.
You know what? It would be really awesome, and I would imagine that the Okule fishermen probably already have some information like this. But if there are days when the tourists don't come, if there if there is more Okule, and it might take longer than one day for the Akule to kind of get comfortable again. If there has been a lot of activity, we saw that it took something on the scale of a few months for those white-tongued jacks to come into Molokini. So it might need more than a day of rest for the Akule school to realize, hey, this place is no longer a zoo. Maybe we can go back there.
I was thinking more in the lines of akule are in there because of the predators on the outside, and if
Hmm.
you chase away the predators, then they will go into another bay and seek shelter there or whatever. But it,
Hmm.
there must be some correlation between uh, the presence of people and what happened.
Hmm.
Thank you.
And I think that's a really good example of a user conflict, right? Because you want to have, some people want to have a business doing dolphin tours, and some people want to have a business catching akule, and it sounds like the two things are not really very compatible with each other. So there needs to be some way of fairly allocating different activities. And that's not a decision for me to make, but if some activities just get steamrolled out of the picture without there ever being any consideration of the issue, that's also not fair.
Just one more question. Have you presented your studies to DLNR and to HTA?
We have presented to DLNR, and our paper got reviewed by DLNR before we actually submitted it for publication. As to, DLNR is a large organization, right? So I couldn't tell you exactly if all of the decision makers of DLNR are in agreement with our findings, but I certainly know that that some of them are interested in adding the impacts of tourism and human presence to their kind of the picture for management decision making.
Oh, no, thank you.
We have not presented it to the Hawaii Tourism Authority. Actually, was that the other question that you just said? So that's a really awesome idea, and I should follow up with them. Yeah.
Interesting. Anybody got any questions? I guess a question for you, Kevin. A lot of our folks are fishermen, farmers. A lot of our folks kind of are proposing community-based efforts to restore their places, right? Are there, like, what would be your advice or resources that communities should look into to like document changes that they see, their environment?
I guess, I don't know if this is going to be useful because it's stuff that everybody is probably already thinking about, but as much as possible to have information written down of all of the possible causes of changes. So, like, for instance, if you're a fisherman, you're already monitoring the fish, and the fishery biologists always like to also try to quantify how much fishing is happening. But a lot of times we may not be quantifying other things that could be important. And so, well, the purpose of this study was, it's not only fishing, it's just having a lot of people in the system that can be an impact. But if there's major things happening, like changes in water quality, all of that kind of stuff, I don't think that's going to be new to anybody. Those are always things that are on the radar screen. But having the records going back in time is really, really important. Actually, the reason we were able to do this study is because Alan Friedlander and company had already been to Molokini 20 years ago and done a ton of dive surveys, and then DAR had started their dive survey program several years before the COVID pandemic happened. So, it was having those historical records that enabled us to do this study. So I guess just having everything written down, even if it doesn't seem like you're going to do something with it today, you may, those records could be critical in 10 years' time or something like that.
Right on. Any other questions? Maybe can you talk about the acoustic tags?
Oh yeah.
Neodymium.
Let me see if I have somewhere I have another video that shows that. So the acoustic tag is a little, well, actually I have one right here. If I can find it. So the acoustic tag is, I'm going to turn off my fancy Zoom background because, well, sorry, Nigel, we're going to have to go back to the dungeon.
Back to the dungeon. It's all good.
Back to the dungeon. Okay, this is what an acoustic tag looks like. It's a little thing, kind of the size of a little battery, and this magnet on here is just magnetically keeping the tag in the switched off position. When you take that magnet away, it turns the battery on. So we're actually going to cut a tiny little hole in the belly of the fish and stick this thing in there. And there's different size tags for different size fish. And this thing is going to make a little noise. It's just going to go like once every several minutes, make some little click. That click actually has a serial number encoded acoustically in the click. And then we have all of these kind of tennis ball can sized receiver things. This is what is put on that rope in a fixed position, and it's just sitting there, you know, for several years listening for those clicks. And so when that tagged fish swims by this receiver, we know that the fish was there. So let's say we put this one receiver on the inside of the crater on the west side, and we picked up a click. We know, okay, that's Omilu number 7 was there on that day. And then the same Omilu we picked up on the outside wall, perhaps the next day or something like that. That enables us to understand what the behavior and habitat uses of the fishes are. So we can kind of understand what the behaviors of those things are. Let me try to. Okay, are you guys getting a picture of like a light green V board?
Yes. Yes.
Okay, so we catch the fish, and we're keeping seawater flowing through, getting our measurements, and then there's a little acoustic tag right there, going in, and then we're just sewing it up with the same kind of surgical suture you get if you go to the hospital because you crashed your bike or something and you needed stitches. And then that fish goes straight back into the ocean. And so now that fish has that tag in it, which is going to make those acoustically encoded clicks that can get picked up by the receivers.
That's not a GPS though, yeah?
No, and so this is really important. So if you know, because we're all used to having our phones that always tell us where we are, and then if you look at any of the wildlife studies of land animals, you know, of like lions and bears and whatever, because they're in air, radio signals travel through air, but radio signals do not travel through the ocean. So like if you ever were floating in the water because you fell off your boat and you're calling on a little handheld VHF radio, you put the VHF radio antenna even 1 inch below the surface of the water, you cannot call for help. The antenna has to be in the air. We cannot use that type of technology with fish because the radio signal doesn't travel through the seawater. That means that the quality of tracking data that we're getting is not nearly as good as what you would get with a radio tag, like a GPS tag on a land animal or a bird. So it's not like we're following this fish everywhere it goes for the whole year. What's happening is if I go back to, let me try to find our map of oh man, I took too many slides out of this presentation. We put our receivers in 7 different places. Oh, I'm not sharing, am I? Share. Sorry, guys. In this little map of Molokini, we had receivers in 7. We had 4 on the outside in the red zone and 3 in the blue zone. So the type of data we're getting, it's not showing you in detail exactly where the fish is swimming. It's telling you, okay, fish is in the outside red zone on the east side, or fish is in the inside of the crater. It's kind of a little more coarse than what you might imagine for when you hear the word tracking. So that's, we don't have that really, really granular, detailed level information of like literally following it around everywhere.
Very cool. Okay, last one attached to that, and Uncle Damien. How long did it take to get the permit to do that study?
Okay, this is, I hope I don't get in trouble here. How many people in this call have applied for permits from DAR or DLNR to do research studies? Anybody? I was chatting with Uncle Mac Poi Poi a little while ago, and this subject came up, and he just laughed. And he said, oh, when you apply for a permit, you realize I already applied for this permit to do the same thing, but I made the application 3 years ago and I never heard back. So then I applied again and forgot that I had made the first application. So it can take a crazy amount of time to get a permit. It took me 2 years to get a permit for a different project. This study, because this was a priority for the state, we got our permit in less than a week. And that was great for this study, but I guess it was one of those who you know kind of a situations, because everybody else who needed a permit was not getting a permit, and we got one in a few days because of the particular situation, and the COVID emergency, meant that this was very time sensitive. But I don't know, they need to hire some more people to work in that department because it takes forever to get a permit.
Right on. Thanks, Kev. Uncle Damien, I know you had one more question.
Yeah, first of all, I heard they hired some more people to help with the permits, but I don't know
Oh, great.
if they finally got them into the position. But regarding your tagging system, have you tried to tag fish that are not as hardy as the Omilo, like Lopelo or mackerel?
So I think you're right on with your comment, because the hardiness of different species changes so much. I have done tagging studies with bottom fish, and I don't think it was the fish themselves that are not hardy. The problem is the depth change. Because we brought them up and their eyes were all bugged out and everything, and we use the drop shot, the drop shot weight technique to take them down really fast. But even with that, our survival rate with bottom fish was about 10% at best. So you tag 10 fish, 9 of them died. And what was happening with the bottom fish is, I don't know how many people bottom fish in this crowd, but there's always predators when you're bottom fishing. And so our fish, we would tag the fish, we send him down on the drop shot, he gets back out into the natural environment and swims straight into a shark. And so I think there was a huge amount of that happening with our bottom fish study. that's a really different situation than with the omilu. Like we could go catch an omilu at the surface. We were using, you saw that ceramic popper jig. That was the Mark, what's his name? Mark White. I couldn't hear you, Nigel, but I think you know the guy who makes those lures, right?
Oh no, yeah, you said it.
Or Mark White. We were catching a fish on the surface. There's no depth changes, so no pressure trauma. Fish comes on the boat, tagged in a couple minutes, back in the water. Those fish have really good survivorship. When you get down into the smaller size fish, it gets a lot more difficult. I personally have not done a lot of very small species, but there has been a lot of acoustic tagging on stuff like juvenile salmon, because the salmon has a huge amount of research going on for it, because salmon's a commercial species and the hydropower dams, they have a lot of research funding. So I know that there has been a lot of tagging of little fishes. I've tried tagging herbivores before, and one of the really important deciding factors is how tight the gut cavity is. So like if you were to, I haven't actually tagged Nanue, but I think they would work really well because their gut cavity is kind of loose a little bit. Like you can add something in there and it's not already fully packed. Whereas when you look at the surgeonfish, their gut cavity is like already so tight that you try to add any additional thing in there and it's like you're forcing it in there, and you're injuring things if you push it in hard like that. So it's really critical to consider the exact anatomy and biology of the fish that you want to study for those types of tagging studies. Like an uhu has tons of space in the gut cavity. Like you could play a volleyball game in there. That would be an easy fish for tagging because you're not forcing anything in there. It's really loose. Whereas the surgeon fishes were like, they're really hard to get those tagged.
So Opelucan would be hard. Or what you would do? How would you tag? How would you follow that fish? I guess is the question.
If you wanted to do Opelu, they make these tags really small. They have some that are a diameter of 7 millimeters. So that's smaller than the diameter of a pencil. So they have really, really small tags that you could get. I guess what I would want to do with something like an Opelu is probably one of the biggest problems is when you release a fish back out into the ocean is whether or not that fish is going straight into a really dangerous predator-rich environment, or it only takes one predator, right? If there's one Alua there and you release the Opelu, he's done, right? So with that situation, I would want to have a setup where I thought that my tagged Opelu somehow had a good chance of recovering for a little bit of time before having to face any kind of natural dangers. One thing that you possibly could do is if you could set up some kind of a net pen and put a bunch of Opelus in there and then tag and put them back into the net pen and then leave them in there for several days and then open the pen and all the fish swim out together, then your tagged fish, he's been safe for a couple days to recover. He's with all of his buddies in the school, properly swimming with the school. Because the one fish that's swimming the wrong direction is the one that gets nailed, yeah? So if you tag the fish and try to throw him straight back into the Opelu school, he's all disoriented and he's the one who's not swimming properly with the rest of them in formation, and that's the one that's going to get nailed. So I'm not saying it's impossible, but it's way harder to tag something like an Opelu than it is to tag an Alua. It's much easier to tag the bigger predators because they have so few natural enemies and they can go out in the environment and they can be disoriented, but they don't get killed. they just swim around with a hangover for a while and then they're okay.
Solid. So interesting. Anybody got any other questions or comments? Otherwise, I'm gonna call it. Thank you so much, Kevin, for making time.
Yeah, absolutely.
Sharing about your research. As folks review the video, if they have comments or mana'o, I'll be sure to share it with you. So mahalo nui, mahalo
Excellent.
everybody for coming by. Have a great rest of the day.
Thank you very much.
Aloha.